You are welcome to this session. So I always remain Wilson. So today I'll be discussing the other type of allegation calculation, which is the allegation alternate calculation. We have already done allegation media calculations. So what is allegation alternate? Now we have done allegation media, the C1 and the V1, the relation and the concentration. So now you're doing allegation alternate calculation. So this is a method used to determine the proportions of different strength of products, or they could be ingredients or excipients needed to make the required strength of a pharmaceutical product. So you can see that in these calculations, we're having products of known strength and we're preparing a known concentration. There is no quantity. This is a method that allows pharmacy professionals and other professionals to calculate the number of parts or proportions of two or more solutions or products when they are to be mixed together to prepare a mixture of a desired strength. So in these calculations, what we get are proportions or ratios or parts of two or more solutions and how they should be mixed after the calculation. But we already have the strength and the desired strength. So now the procedure here involves convert all the data in similar forms. Here, what do I mean? Sometimes the question could have an excipient and an active, as we shall see in a different calculations which are going to follow. So if they're all excipients, ensure they're excipients. In case they are active, in case they're active, ensure they are all active. So now so make 3 columns. As you can see, I made 3 columns here. 1, 2, 3. Write down the strength or the concentration of the components to be mixed on the left. This is my left, with starting with higher concentration product, that one to the lower concentration product. So I can call this one my concentration of a higher, this one a concentration of lower. Now in column 2, this is column 2. In column 2, write down the desired percentage strength of the mixture to be prepared. Can I give a different color? For example, is that one. So apply alligation, subtract diagonally. What does this mean? Subtract this from this, you get a product. This for this product here. Subtract this from this, you get a product for this here. So we can use arrows, which I didn't want to put at first, and show you how they come about. So you can use arrows. So now the proportion, this purple proportion is for this one, and this blue proportion is for this product. So that's the allegation alternate. You are subtracting this from this, getting this, and this from this, getting the ratio for, or the part for this. Now, after this, we get the relative proportions and the components of the components. Then we make further calculations as the question directs. Now, during the calculations, the percentage sign is silent or ignore the sign, because as you're going to see later on, you're going to divide a percentage and a percentage and it will go away. So we subtract numbers. In case of a negative sign, ignore the sign. We always subtract the bigger from the smaller, but in case you are getting a negative, we don't use negatives. We just ignore them. In case the concentration of the product is not indicated, if it's an excipient, as we saw earlier, it is 0. The concentration is 0%. And if it is a pure product, the concentration is 100%. Now, I will always repeat this statement that in case a diluent such as sodium chloride or dextrose are to be used, their concentration should not be considered. So, because this is always confusing students and any other health workers, that because we are seeing very many concentrations in the question, so you get confused. But just know that in case you are giving sodium chloride 0.9% to be used as a diluent, its concentration is 0. This whole thing is a product, as we saw in our earlier product identification. Specific gravity can also be used instead of concentration, and sometimes can be given percentage of the excipient in the product. In these instances, first get the percentage of the active. This explains my point 1. Ensure they are all in the same form or same unit. That sometimes you can be given the percentage of the excipient in the product. In these instances, first get the percentage of the active by subtracting from 100%, because in that instance there are always two products. So this is I've explained the procedure in case of two products, A and then B. You're required to prepare C for a child. So make 3 columns, 1, 2, 3. You can see 1, 2, 3. It is good to indicate this for what you are calculating for. A ointment, B ointment, and then you're calculating C. Subtract A minus C. Put A minus C here. These are parts of B, as you can see. B minus C, as you can see here, to give you the parts of A. Now, remember, this is where the alternate is. This is where the alligation alternate is. So sometimes we have 3 products which are to be mixed here. The ratios are different, but for consistency, it is always advised to always pair a stronger product with that one, with the weaker product. So in case there are 3 A, B, C, this is how you put them. Remember, you start with the higher, then that one, then the lowest one, then also indicate the one which is desired to be prepared in the middle. A minus D gives you. So I have to first pair the big and small concentration. So I have A minus D. I put it here. Then C minus D, I also put it here, or D minus C, in wherever where you want it. So that one have paired those two. Again, you pair this middle one with the lower one. Here you have 2 pairs. Now you are dealing with these ones too. So you subtract, you alternate C minus D, you put on B, and B minus D, you just add it on the other earlier one, A minus D. It is good to always indicate parts of this, parts of this, parts of this, and that's why we have written the products here to show us on what we have done. After that, you write the ratios. This one, they may look similar, but because of units, maybe they could be a bit different, or they're always similar, depending on your calculation and the question. This is a question which I have tried to calculate for us. It is in 3 parts to show us the different calculation which can come, or which can be asked. So in what proportion should ethanol 90% and ethanol 40% be mixed to get ethanol 70%? As we said, we make 3 columns here. I need to put the columns 1, 2, 3. So 1, 2, 3. It is alcohol 90%. Indicate the figure here 90. Alcohol 40, indicate the figure here 40. Lower, sorry, the bigger one to the lower concentration. What you are supposed to pay is always put in the middle, and then we do the alternate, or we subtract. 70 minus 40 giving you 30. 90 minus 70 giving you 20. If here you chose 40 minus 70, it's the same thing as negative 30, but as we said, we ignore the negatives. So after you have gotten these proportions, it is good you come to get the ratio of how they should be mixed. So I have ethanol 90% and ethanol 40%. Of course, these ones we have V over V. Also here we have V over V. Yes, we always have this V over V. So after you've gotten them, here the same principles of what we did in the ratios apply. You have to always reduce them to the smallest. It's good to show what you have done by dividing by 10 by 10. So this is how they should be mixed. Now, so it means that you can conclude by saying that we will need 3 parts of alcohol or ethanol 90% and 2 parts of ethanol 40% to make 70%. Make 70%. So part B, from question 1 above, if the required amount of ethanol of 70% is 65, how many mils of each should be mixed? So here they have given you the total to be prepared. So get the total ratio, which is 5. 5. The amount of each is its ratio divided by total ratio times total volume. These ones we have done them before in the working formula. So amount of ethanol 90%. It's good to indicate what you are calculating. Some of us calculate like calculate the way we want. Just go and then start calculating. No, indicate what you are calculating. Its ratio, which is 2 out of the total 5 times 65. I get this. Also amount of ethanol. It's good you can conclude 26 mils of ethanol or 90% volume per volume ethanol should be mixed with 39 mils of 40% ethanol to get 70% volume per volume ethanol. So you can conclude like that. Now, this is the question 2 when I give a total volume. However, see, if from question A, if they gave you only the volume of 1, they say that if 2.5 mils of 40% volume per volume ethanol is available, how many mils of 90% volume per volume ethanol should be mixed? In such instances, we have seen from how we got the volume of how we got the quantity of ethanol 40%. It was its ratio divided by this times total volume, which means that in this question, what we have the ratio of 40% total ratio and also amount of ethanol to be prepared. So I just get this total volume, I make it V or N later, then 25, then you substitute in the equation, and then this is what you will get. Total volume. So 25, 3 out of 5 times V. Total volume will be 41.7 if you put this one in the calculator. So now the amount of ethanol, 90% volume per volume, will be total volume minus quantity of ethanol, 40% volume per volume. Then you get your 16.7, as you can see here. So these are the questions which at least I've tried to search for. Of course, there are more, as we shall be proceeding in our calculations, which we shall be practicing. And I have more questions in the quizzes. Always try them in our classroom.